Welcome to Pandas GroupBy, grouping real-world data in Python. My name is Christopher, and I will be your guide. This course is predominantly meant for someone familiar with Pandas already, but does include refresher material. The refresher reminds you how to create a data frame and manipulate the data within it. Once you've got a data frame, you can run operations by grouping content together. You do this using something called the split, apply, combine pattern, and you use Pandas' built-in methods to operate on the groupings created through this pattern. Or you can also provide a Python lambda as well. Finally, once you've seen several different ways of grouping on 3 different sets of real-world data, I'll wrap up showing you how your choice of approach can have a big impact on the speed of your code. The code in this course was tested with Python 3.12 and Pandas 2.2.2. None of the Python here uses features specific to Python 3.12, and so any currently supported version should be fine. Pandas, on the other hand, has changed a bit since version 1, so beware if you're not running the same version I am. Pandas is a powerful tool for doing data processing in Python, and it has the advantage of being written in low-level code, meaning you can get much better performance than an equivalent pure Python program. Pandas sees the world in the terms of tables and columns. This is similar to the structure of an Excel sheet or a table in a database. There are all sorts of things you can do on the tabular data, including slicing parts of it and running calculations. This course is about grouping parts of your data together and running calculations on the groups. You do this grouping in Pandas with the GroupBy method, which is conceptually similar to the feature in SQL with the same name. Once you've grouped your data together, Pandas provides a whole host of functions to run on the groups, like counting, finding mins and maxes, filtering, and much more. I'll start out with a review of data frames and their operations in Pandas. In the previous lesson, I gave an overview of the course. This lesson is a refresher on the parts of Pandas you need to know for the rest of the course. The focus of this course is the Pandas GroupBy method, and I'm going to be making some assumptions about your Pandas knowledge. If you've never done Pandas before, it might be better for you to start with a more in-depth course, like this one. The Pandas concepts that I'm going to assume you are familiar with are creating and accessing data frames and series objects, and understanding the difference between them. When I say accessing, I mean using .access, square brackets, slicing, the lock and ilock methods, as well as pop. I won't be doing a lot with data types in the course, but you should understand that a Pandas column has type information associated with it, and that type could be a Python object, a variety of integer and float sizes, dates, and there's support for NumPy types in Panda columns as well. I'll be using 4 specific functions from the Pandas module: the CSV reader, the date time column parser, the column renamer, and the set index call, which changes which column is the index. I'll also be using the in-place argument to several of these, so you should understand the difference between the default for many methods, which is duplicate the data frame, versus doing in-place modification. If you need a review, or 1 or 2 of these concepts is new to you, don't worry, I'll cover that first. If everything I've mentioned here is old hat for you, feel free to skip forward to the actual GroupBy lesson. Okay, let's start the review. Pandas is all about playing with data, and its main model for doing this is very similar to a spreadsheet. In memory, you store data as a series of rows and columns. This storage mechanism is based on a class, which is the central idea in Pandas, a data frame. In Excel and other spreadsheets, you can identify a single cell by referencing a column and a row using a letter and a number. For example, B3 is the second column and the third row. You can tell it's a non-programmer's tool because it doesn't start at 0. A data frame does something a little different from that. Instead of using the alphabet to identify a column, you give each column a name. This is typically done at creation time, but can also be modified. Most CSV files have a header row which names the columns in the file. A data frame does the same thing. You can use this column name to access the column in the data frame in order to manipulate it. There are also ways of doing it by number, but I'll come back to that later. Instead of using a row number like a spreadsheet, each row in a data frame gets a label. This set of labels is known as an index. You can provide your own index based on the data you are using, or like with Excel, you can have it automatically created as an incrementing number. Pandas also has its own idea of a sequence, which it calls a series. A series is like a list in that it is an ordered one-dimensional storage, but what makes a series different is that it has an index. A data frame is actually just a collection of series objects, where each series is a column in the data frame, and the data frame and every series within it shares the same index reference. The shape of a data frame is the size of each of its dimensions. In this course, I'll be sticking to two-dimensional tables, so the shape is the number of rows and the number of columns. The shape of a series is the number of items in the series. If you have a series that has the same number of items in it as the rows in a data frame, it can be glued into the data frame. A shared dimension size and common indices are really important later in the course. When you start slicing and dicing the data using GroupBy, the selection of what you are grouping can impact the performance. Okay, grab your bamboo, it's time to head to the REPL and play with some pandas. Pandas is all about manipulating data, so to start off, I'm going to need some data. Let's create a little data set about books. I'm going to use a dict here, and inside the dict, I'm going to have a key for each column, with the corresponding value being a list of content. The titles here make up a column in the data frame. I copied this data from LibraryThing. Good tool, even if the UI looks like somebody's nephew's MySpace page from 2010. And these were the ratings on the site for those three titles. The LibraryThing community appear to be some tough markers. Next up is the author's last names, their first names, and finally the author's birthdays. This dictionary contains the data for 5 columns: title, score, last and first name, and birth date, and 3 rows: Metamorphosis, Time Machine, and Mockingbird. Don't forget, though, Pandas needs an index for each row. I could let it auto-generate it, but then I wouldn't be able to easily map it back to the LibraryThing data, so instead I'll create a list of index numbers. These numbers correspond to the IDs on LibraryThing for the 3 titles. Time to create a data frame. First, I'll import Pandas. It's a very common convention when using the Pandas library to alias the module as PD, like I've done here. Save some typing. And now for the data frame. The data frame constructor accepts several different formats of data. I've used the dictionary above, but you can also do a list of dictionaries where each dict acts like a record. That format is actually pretty common in the real world, as you're more likely to access data as a grouping of books rather than chopped up as columns like I've done here. But the dictionary style that I've used takes up less space on the screen. The second argument to the data frame constructor is the data to use as the index, which here is my list of book IDs. Let's look at the contents. And you can see that Pandas creates a table. Each of our 5 keys from the dictionary becomes a column header. The 3 indexes are there on the left, and each row contains all the data for each book. I've only got 3 books in my data, so it isn't hard to see it all on the screen. But in the real world, you're not likely to be using Pandas just to play with 3 things. You're probably going to have hundreds or thousands of rows. With longer tables, what Pandas will display in the REPL is the first few rows, then ... then the last few rows. You can get at the first few rows yourself by using the head method. By default, head returns the first 5 rows, but here I've given it an argument so it only shows the first 2. And to go along with head, of course, there is tail, which shows the last 5 rows, unless, like I've done, you give it an argument. There's still some more review to come. Next up, how to access things in a data frame or series. In the previous lesson, I did a review of how you construct a data frame. In this lesson, I'll review how to get at the information inside of one. Pandas is all about the data, and as such, there are lots of different ways of getting at the info inside a data frame. Later in the course, you'll be using these to slice and dice to group your data together. Just how many different ways are there of getting at your stuff? Well, for starters, you can reference a column in a data frame using dot notation. In the book example I used in the previous lesson, you can get at that title column using dot title. This only works if the name of the column is a valid Python identifier, so you have to stick to alphanumerics and an underscore for this case. But that doesn't mean you have to restrict how you name your columns. If you've got a funkier name, you can reference the column like accessing the key in a dictionary, giving square brackets and the string name of the column. So much for the columns. How about the rows? Well, remember that each row in a data frame has an index value. This can be a little different if you're just thinking of it as an array, and some accessing can be counterintuitive. For example, you can't just use square brackets and a number, as the square brackets mechanism is overloaded for the column names, which I just described. But oddly enough, you can use a numeric slice. I don't recommend it as it's confusing, but it is there. The data frame is just a big two-dimensional thing, so it might not be surprising that you can get at a cell by using square brackets on a column reference. So that can either be .column name square brackets or two sets of square brackets for column and row. This can also be a source of confusion as the access order is column first, like in a spreadsheet, rather than row first, like in nested lists, or like in row first with .lock. So yeah, consistency isn't this library's best feature. What's .lock? Well, it's an attribute on the data frame, which you can use with square brackets to get at different parts of it. Using .lock, you can get at a row, a column, or individual cells. To go with .lock is .ilock, which works just like lock, but instead of using column names and index values, uses Python-style numeric indices. So if you want to use 0 to mean the first of something, ilock is the way to do it. The final accessor I'll be using in this course is pop, which is like its namesake in a stack. It removes the thing being accessed. Let's go off to the REPL and see all of these in action. On the screen here, I've got the same creation code as in the previous lesson, giving a data frame containing 3 books. And here it is. Let's start by getting at a column. Using the square brackets always works. In this case, returning the title column. Note that what is coming back is a Pandas series object. You can tell that by 2 things. First, the index for each item is present, and second, it has a little data type spec sheet printed at the bottom. The spec sheet tells you the name and type of the data inside the series. Square brackets are extra characters, and as I mentioned before, you can use a shortcut. If your column name is a valid Python identifier, you can use it directly with dot notation. And to prove my point, the type of the column is a series. The column is the first dimension. If you want to get at a cell, you can use square brackets to get at that as well. Note here that 5473 is the value of the index. In this case, it is a number, but indexes don't have to be numeric. This can be a little confusing. If I tried df title brackets 0, I'd get an error. The index to the row is the indice in the square bracket, not the traditional Python counting index. You can see the data frame's index using the index property. 2 things of note here. An index is a Pandas object itself, and when you show it in the REPL, it prints the index values for the data frame as well as the type used to store it. Like the index, there is also a columns attribute. And the columns attribute itself is an index object. This time, the values in the index are the column names, and the data type is object. Note that the default storage for a string is a Python object. And since all of my column titles were strings, they're Python objects for Pandas. You can get at the parts of an index using square brackets. The column name in position 2, that's the third one, is last name. You can see the different types of the columns using the dtypes attribute. Almost everything here is a Python object, with the exception of the score, which it recognized as a float. Note that the birthdays were input as strings, so they're stored as general Python objects. This may not be ideal. You might want to be able to do date math on them, so Pandas provides a conversion method. The toDateTime function in the Pandas module can take a string or a series and will attempt to convert it to a Pandas timestamp object. This is Pandas' own type of datetime storage. If you give it a series, it converts each value in the series into a timestamp, giving you a new series. Lots can go wrong with this. It attempts to auto-detect the format of the date, which can go awry. You can provide a format argument to be explicit about what is being parsed, or there are other arguments like day first that hint that this is a date starting with the day as the first value, as is done in some cultures. Secondly, if you're operating on a series, everything in the series needs to be consistent. If you've got dirty data, problems can ensue. You can specify different ways of handling errors with extra arguments to this call, but generally you're going to have to clean the data. And the one that bit me in the butt when creating this course is the timestamp only supports a range of values. Originally, I included Robinson Crusoe in my list of books, but Defoe's birthday year is 1660, which is before 1677, which is the lower limit of a Pandas timestamp. This doesn't mean you can't store a date like that, it just means it has to stay as a Python object. Converting it to a timestamp gains you lots of speed, but there are restrictions imposed to get there. Note that the toDateTime function is returning a new series. It isn't operating on the existing column. So to actually convert our column in the data frame, you need to reassign it. All my caveats of dealing with dates notwithstanding, that's pretty simple, right? You just assign the column a new series and Pandas takes care of it for you. The resulting data frame looks the same. But when you look at the types, the birth date is a datetime 64 in nanosecond resolution instead of the generic object that it was before. Okay, I mentioned .lock. Let's play with that for a moment. .lock with an index value returns a single row. Passing an index value and a column to .lock gives a cell. The second value to the brackets in .lock is the column. What if you want a whole column instead of just a cell? Well, to do that, you pass a colon as the value for the row. Essentially, it's like an empty slice. And here, you get the entire column as a series. You can also use a colon for the column as well. But that gives you the same thing as doing it without the colon altogether. At least that part's a little consistent. The .lock attribute supports slicing. Remember, though, that indices for the first value are the index values of the data frame. They may not even be numeric. Here, I've used a slice containing 2 rows and a single column, giving me a series in return. Without the column specifier, you get the whole set of values for the 2 rows that were sliced. The .lock mechanism even supports comparison operations. This is all the rows where the last name column is equal to Kafka. Of course, I've only got 1 in my data, but you get the idea. If, instead of using the data frame's index value, you want to use a traditional Python index, you can do that with ilock. Ilock works the same way as lock, except you give it Python-style indices to specify a row, or a row and column, or with slices. Keep in mind, when using ilock, that the indices are inclusive-exclusive, so slicing 0, 1 is the same as just using 0. That's because a 0, 1 slice is from 0 to 1, excluding the 1. Wow, that's a lot of stuff. Next up, what you actually came here for, grouping data in Pandas. In the previous lesson, I wrapped up my review of Pandas by showing you how to access different parts of a data frame. This lesson starts what you came here for, learning how to group data in Pandas. Consider this table of data. If you wanted to count how many people liked apples using a Python program, you would loop over the data and increment an apple counting tracker. Or you might get fancier and use the counter object from the collections library. If this data were in a Pandas data frame, you could do the same thing, but it wouldn't be the fastest way of accomplishing the task. Pandas has been built for speed, which makes the slow-moving fuzzy animal it's named after a little bit ironic. Most of Pandas, the library that is, isn't written in Python, but in a lower-level language that is closer to your hardware, thus giving better performance. So instead of looping through all the rows, you could first group the rows together based on an attribute. In this example, I'm grouping the fruit column, and then I could count either what was in each group, getting all of the totals, or just the ones that matched apple, if I preferred. The process of grouping to do calculations is called the split, apply, combine pattern. It's a 3-step process, where the first step is to split your data into groups. The second step is then to apply some function to the groups, and then finally combine the resulting data into a structure. Approaching the fruit table from before, you split the rows based on the type of fruit, apples or pears, apply the count function to the number of items in each group, and then get a combined data frame containing the names of the fruits as indices and the fruit counts as a column. When you perform a group by split on a data frame, Pandas uses the criteria you give it to create a series of subsets from the data. You can split based on the name of a column, which is by far the most common way. This is like using fruit in the example I just mentioned. Or you can split based on a list of column names. Say our fruit example had another column called variety. This would then treat apple Granny Smith as one group and apple delicious as another. In fact, the column names are just shortcuts for actual columns. You can use column accessors to pass an actual column in as your grouping mechanism. Additionally, you can pass in a function which gets called for each row, and then grouping is based on what gets returned, or you can pass in a series that maps row index labels to group names. Later in the course, you'll see how carefully selecting the right series, remember that's what all columns are, can make a performance difference on your calculation. Once you've got things grouped, the applying phase performs some action on the groups. Pandas breaks the kinds of functions that you can perform in the applying stage into 3 types. Aggregates compute a value based on the data in a group. This is things like counting the number of things in a group, summing the values in a group, or calculating their average. The next set of functions are transforms. These use the values in a group to perform a calculation. For example, cumulative sum adds together the values from groups. Back to the fruit example. Still with the varieties column, now let's add a price column. If you grouped on fruit, you would see a row for Granny Smith with its price, and then delicious for its price, and you could cumulative sum across this. It's a bit of a contrived example. I don't know why you would do that with apples, but hopefully you get the idea. The third set of functions are filters. These chop up the groups, dropping some of them. You've already seen head applied to the whole data frame. Well, you can run head on a grouping as well, giving just, say, the first 5 groups. There are mechanisms within the grouping to determine how things are sorted. So in this case, your first 5 could be the 5 groups with the highest score. For a full list of functions available, see the GroupBy page in the Pandas docs. Although the pattern is split, then apply, then combine, I don't have much to say about combine. Pandas just does it for you. The return result of the apply stage is the combined data, typically as a data frame. So now that you've got the concept, let's see how it actually happens in code. To perform a grouping operation on a data frame, you use its GroupBy method. The value you pass to the method is the splitter. In this case, I'm splitting on the kind column in the animals data frame. This operation returns an object. More on that in a second. And then the apply functions get called on that object. Here, I'm using the sum function. which in this case gives the total height and total weight for each of the rows whose kind column is cat, and then for each of the rows whose kind column is dog. Finally, the combine portion of the operation is done for you when Pandas returns a data frame containing the result. As I mentioned a moment ago, calling the GroupBy method returns an object. For data frames, this is the data frame GroupBy object. This object is the one that contains the apply methods. This kind of method chaining allows for the calculation to be lazy. This means that nothing gets calculated until you go to use it. By using it, I mean accessing some of its results, or in the case of the REPL, printing it out. Big advantage of this laziness is that you can chain things together at almost no cost, and you're pushing all the calculations down into Pandas rather than doing it at the Python level. This keeps you speedy. Pandas is a fast little bamboo-chewing biochromatic fuzzball. Now that you've got the sense of GroupBy, it's time to write some code.